I come from Stellenbosch, from the Department of Forest and Wood Science, and what I'm going to talk about this afternoon is fire-resistant wood composite products in building applications. So basically, the project that we are doing with the group is part of that. I don't know if that makes sense. So our overall aim is to look at these materials. So as part of that, we are doing a geopolymeric composites as well. So now the arrow is this one. So I'll talk about our university, of course, our department, and how do we try to respond to challenges facing a modern society. Then I'll talk about our group and what we focus on. I've already given you a clue. Then what are we doing currently, and also the outlook. So that is our university. So it is situated in the Stellenbosch area. That is the Western Cape part of the country. So Stellenbosch is popular for its winemaking. So as you can see there, so we call it the wine region of South Africa. So it is a leading public university. It was founded back in 1866. The current chancellor is Johan Rupert, and the vice chancellor is Professor Wim de Villiers. We have something like 1,000 academic staff and about 2,000 administrative staff. Students about 27 to roughly 30,000, of which about 18,000 are undergraduates, and about 10,000, those will be your postgraduate students. So here I think you mostly have institutes, and I think in your, so as we're using we have faculties basically. So we have something like 150 departments within those faculties. So we have arts and social science, science, education, law, and so on and so on. At the bottom there is agri-sciences. So agri-sciences is the faculty under which we belong. So that is our department. That is the Department of Forest and Wood Science. So we have also what we call satellite campuses. For example, we have the military science that is in Saldanha Bay. That is far away from where we are. And the health sciences are in Tygerberg. That is between Cape Town and Stellenbosch. They're in the middle. That is the same for the business school. There's a place called Belleville. So it's somewhere in the middle. So those are satellite campuses. So as I mentioned, we belong to the Faculty of Agri-Sciences, and Danny Brink is currently our dean. So this faculty was established in 1918. So it is one of the oldest, in fact, it is the oldest faculty in the university. The university celebrated its 100 years last year. So this, that is, as it was formed, the faculty was also formed. That is back in 1918. So earlier today I was talking with Bernard. He was telling me that here you have the Department of Physics, Chemistry, and so on and so on. So I was telling him, at Stellenbosch, I'm the Department of Chemistry, alone. Then Martina, that's Physics, alone, and so on. Just 3 people. So we're a very, very small department. So in 2006, we used to be the Faculty of Forestry. So, but now we started merging. That is, all agricultural departments merged to form what is called now Agri-Sciences. Also, our faculty, the Faculty of Forestry, became a department, and we also merged under this Faculty of Agri-Sciences. So we have something like 1,300 students, of which 461 are postgraduates, and we have 11 departments. So we are one of the smaller departments. So we are forestry, then there's horticulture and all other departments. So it's agri-sciences basically. So now let's talk about us, the Department of Forest and Wood Science. As I already mentioned, we're a relatively small department. So what do we do, small as we are? So as you can see there, we don't have a ratio problem. So that's 100% women. So those are our students. So that is, so what do we do? So our core business is, of course, academic service delivery. So that is like everybody, that's what we do. That is, we teach the forestry education. Like we're the only university that teaches forestry from the seed all the way to the product in South Africa. So others will focus on diseases, for example, that is Pretoria. They have an institute which focuses only on diseases. So we teach the whole offering, that is from the seed all the way to the product. So we offer this service, of course, to the tertiary education sector. We also offer it to the commercial sector. That is, we work with companies, try to solve problems. We do training for the companies. Also the African Society. So that is, we have students coming from all over the continent to come and study in Stellenbosch, and also the global forest sector. So we play a role there as well. So as I mentioned, our business is academic service delivery to postgraduate and undergraduate students. Number 3 is community interaction. That is what we do must be reflected outside. So we need to service the communities outside our environment. So we do a lot of collaboration with African civil society as well as the global forest sector. So now the topic that I'm going to talk about here is what is called the South African Housing Challenge. So this is not unique to South Africa. Other countries as well in other continents have the same challenge. So if anybody has read anything about South Africa, we come from a dispensation which we called apartheid, then we've moved to democracy. So this has caused huge imbalances in societies. That is, you have they say South Africa is the most unequal country in the world. That is, we have the richest people and the poorest people. So it is the most unequal country in the world. So because of this separate development, which was made into law through the Group Areas Act and the Bantustans and so on. So, but now under the democratic regime, things have changed. So we try to reverse that. So what the government has tried to do is they came up with what they call the RDP program. That is a reconstruction and development program. The idea is to offer everybody a place to live, so to speak. So they built, as you can see, those houses on the top right, very small houses, but at least there's running water, there's electricity, like services. But that is not enough. A huge majority of people still live in shacks. As you can see the numbers there, about 3.6 million people live in shacks. That is the population of a country. But it is not unique to South Africa. Other countries have the same problem. For example, Namibia, they say almost 1 million people live in shacks. Shacks are tin structures, so to speak. So this is a problem, like in other countries as well. If you go to the east, you'll see these issues as well. So one of the problems with shacks is fire. So that is a huge problem. As you can see there, this is just a screen grab from a Google search. So as you can see the hits that you get. So Alexandra, all these places, fire is a huge problem. Of course, it may be due to spatial planning. That is the way the things are built, and also the materials that people are using. And of course, there are no services, no running water, no electricity. So use of candles and whatever thing that people can use to warm themselves leads to these fires. But this, again, is not a unique problem to South Africa. Other countries as well will have the same problem. So, for example, you can see, I think we've seen these pictures on the bottom right. That is in London. There was a fire there in the building. It's a first world country. So it's, as I mentioned, this happens the top left. That is Dubai. So there was a fire there as well. That is the Knysna Golf Club. So it's a golf club. That is high, what do you call, affluent people go to those places, right? So there's a fire there as well. So this happened, I think, last year. So as you can see, RDP houses on the right-hand side. You can see in the middle, that is a fire that razed that whole area, leaving hundreds and hundreds of people without a roof under their head. So fire is a real problem, right? So spatial planning, yes, but also the materials that we use. For example, I think as we have heard in the tower in London, that was the materials mostly. So now going back to what we try to do as a department, we try to solve these problems, so to speak. Of course, we cannot provide whole solutions, but our academic offering and research is guided by these. So now let's talk about our group in response to these. So what do? We're looking at fire retardant building materials. So as you can see the top left, the first project that we did on this was, I think it started from around about 2015 or so, where we're looking at phosphate-based composite materials. That is, we mix magnesium oxide and phosphate to make a paste. We mix it with wood particles. We make boards out of that. So this has been ongoing. We had one PhD student who graduated in 2017, an MSc who graduated in April this year, and another one at the end of this year. There's another one who graduated. So we've been involved in this for some time. So we are also looking at fire retardant wafer boards. As you can see there, so that is your wafer here. This is it's a paper board basically. So, but as you can see, if you can track that arrow, that is a beam that is made out of that wafer board, right? Like what they do is that they take the wafer board, then they print the grain of wood onto that thing, and it looks like a real beam. right? But it is not fire retardant. In the US, this company, the company, Hamed is very much involved in this project there he is. So this company is trying to penetrate the US market, trying to sell this because they are very light. It's paper, isn't it? And actually it's quite strong. If you stand on top of the thing, it's quite strong. So, but they cannot penetrate the US market because these things will burn, right? So so this is one of the things we're trying to solve this problem. So they are also, this company is now going to, with all the refugee crisis in Europe, like Syria, so they are going to build refugee houses with these materials. Very light, easy to transport, very strong, fire and water. Those are the only two problems. So we're involved in that. Geopolymer composites, of course, so that is the topic that I think Hamed will discuss in the next 30 minutes or so. Yes, Hamed, yeah. Yeah, so he's looking at that. Now, on your far right, we have cross-laminated timber, CLT. So CLT is a very popular material these days. In South Africa, we have it. It comes from spruce. We import it from spruce. It is made from spruce from Europe. So, but here, the environment is such that there's no need to treat the material with chemicals. You can use it as it is. But in South Africa, we have moist environments like the whole East Coast. There's high humidity. So there's a requirement to treat wood products with preservative chemicals. So that's one. Two, fire. We need to treat it with fire. So this is a project that we started this year. We have 2 MSc students and a PhD student looking into this. So we're looking at fire treatment, but we're also looking at preservative treatment. That is to preserve the wood against degradation by microorganisms. So on the far right, that's me, that's chemistry, and Martina, physics. Those 2 departments working together. So that's us. So now, we're not the only people who are concerned with fire. Our colleague from across the road, I think that's where you were. The demand of chemists that is civil engineering across. With Dr. Richard Walsh, so he's got an institute there. They are modeling how fire spreads. Like, as you can see that picture, the fire just went through the whole squatter camp, and so now they are modeling how fire moves, and they are also working on detection systems in informal settlements. So some of the products that we do are going to be tested in this lab. So they are at the moment designing a furnace where you can take a whole product and put it inside and test its fire retardance. It's very expensive, but this is something that we're going to do. I think it may happen that we test some of Hamed's products in there as well. Even if we don't test them there, but we'll look at some fire retardancy and such aspects. So that is everybody not everybody, but at least there's a huge focus on fire, that is especially now in university. So this institute was given millions of francs to start this, so they've been going now for some time. So geopolymer composites. So as I mentioned, Hamed, that's him. So what are they? So as I mentioned, the focus for us is to build or is to manufacture products that can offer some form of resistance to fire, isn't it? So geopolymers, of course, cement-based materials can do that, isn't it? They've been there for quite a long time, but geopolymers, people believe that they have a better impact on the environment. So we can use them, incorporate them into wood particles, and make products out of that. So of course, they are fire and acid retardant, and they have high AE strength development, and just mentioned the energy requirement is not as high, and you can use a whole lot of materials that are otherwise considered as waste to incorporate them and to make the products. So that is our focus. So here, these are your fly ash or slag. So that is the geopolymer part, but we are also looking at the wood part, right? So we're not using just any material, we're using material that is otherwise considered as waste material, like your sugarcane bagasse. Of course, sugarcane bagasse is not a waste material, or maybe let's call them byproducts, not waste materials, byproducts. So we use those. We use a wood coming from what we call alien invasive species. South Africa has its own indigenous forests, right? But we had to import or bring in some wood species from other countries like Australia, your eucalyptus, the pine from Europe, and so on, to supply to build some wood reserves for the country. So, but now these species are thriving in South Africa, so they are spreading all over the place. It's not only wood products, but other plants as well. I think even fish. So these are all considered alien invasive species. So they invade the space and they take over. So, but now the government has started a program to clear these. Of course, it's never going to end, but they've started. And they want some money back out of that because they have waste material. So this is some of the things that we're trying to do, that to try to use this waste to do something with it. So there are challenges. I think Bright has spoken about some of them, and Hamed has listed some here as well. That is the low tensile strength, the workability of the paste. About the tensile strength, what we've done with another project, just to cheat, the things are not strong, right? So all we've done is just we've laminated them with pine, with veneer, both sides. And the thing is very, very strong. So that's what we've done to solve the problem. Of course, pre-treatment of the material, that is getting rid of some, improving the fiber properties, then the material can bind better. So Hamed's project is aimed at developing wood fiber geopolymer composites. I don't know what is happening there, but one of the things that he's trying to do is to incorporate ox blood into his mix. So why ox blood? Hamed believes that it improves water retardancy of the products, and there's lots of it that is available. So I think that is objective number 3 or so in his project. So we'll see. He still has a lot of issues to sort at the moment before getting to that. So, of course, to characterize the physical, mechanical, and thermal properties, of course, fire and the thermal properties of the product are also important. So then he will look at the durability in freeze thaw and the fire exposure. So those are some of the things that he will do. So we hope that we can have an impact as far as waste management is concerned, because as we mentioned, all the components that are used here are materials that are otherwise byproducts. So this is supposed to have an impact. And of course, we hope that we can contribute by creating products that are affordable and that can be used to build houses. So we just mentioned houses is a major challenge for us. So we hope, of course, in South Africa, if you talk about houses, you're talking about concrete, isn't it? That's all and nothing else. So we hope that we can promote the use of wood, or even if it's not wood as in solid wood, but composite products by making or developing these products. So we've worked on phosphate-based composites as well. Like one of the key ingredients is magnesium oxide. So, and also we use the phosphate. So this is known to be a fire retardant as well. So some of the things that we have in there is fly ash, we have kaolin, silica fume, calcium carbonate. We've tried these, and what I can tell you is that calcium carbonate has performed better as a filler in the products. Silica fume, we've tried that. Kaolin, we have not tried. I'm not sure, Hamed, you have not used kaolin for your geopolymers. Kaolin. Metakaolin, yes. So fly ash that we have used. So here we use this magnesium oxide with phosphate. The other metals that people use as well, like aluminum oxide and so on and so on. So you mix with this. So these, I think I was having a discussion with you when we're coming back. The strength is good, right? That is the strength that you get, but the product or the paste is very expensive. That is, you have to buy the magnesium oxide and mix it with the phosphate. I mentioned that a bag of cement in South Africa costs less than 100 rand, so divide that by 14. So, but this paste costs more than 1,000, so it's 100-fold more expensive, isn't it? So, but from an environmental perspective, it is considered to have less impact. So I think that is, yeah, if we go here, we can say, there we say that only 41% of the total energy is used. And also the processing and production of phosphate binder emits 20% less energy. So that is the angle that we are coming with. Of course, this has been used for a long time to repair cement structures. So, but we want to incorporate it with wood and to make products out of it. So if we go back here, of course, you can, If you have 100% magnesium phosphate, then you'll have a very strong material. But now, because we incorporate wood, some of those properties tend to, that is the MOEs and all these things, now they get reduced. So, but they are fire retardant, they are water resistant, and the strength properties are quite good. So, hence we are venturing into this. So, and one of the things is that the sugars that I think we mentioned, which affect the hydration rate. So here, these are not a problem. So these phosphates are not affected by that. So our aim generally is to investigate the possibility of making products out of these phosphates together with whatever wood we can get. And as I mentioned, we've been at this for a couple of years now. We've done the economics. They're not good. So the thing is just expensive. And some of the things that we looked at a pulp mill sludge as a raw material incorporated with this waste. So at least there are some good numbers there as long as you do everything in one place. That is, the pulp mill sludge comes from the pulp mill and you have a plant that makes the same product at the same place. So a pulp mill sludge usually has a lot of water. So if there's energy at least, then that's okay because you can get rid of some of that water. But as long as you do it at the same place, then that's okay. But South Africa is a large country. So most of the mills are in KwaZulu-Natal. So for example, there's Kimberly-Clark. I think Kimberly-Clark is a global company, we all know them. They make tissue. So Kimberly-Clark doesn't pulp, right? They use recycled material. So now we're using waste from them as well. So those are things that you need to consider. That is the distance between your source. So it's very important for the economics. At least like that, it is promising. So with this project, we are at a stage now we're just fine-tuning. We've done most of the material characteristics, so we know what works and what doesn't work. So now we're just looking at designing actual products. One of the things that we're focusing on is ceiling wall, ceilings, tiles, the ceiling tiles and partitioning walls. So that is the final project that we are doing. So all the materials that we've made have passed the standard, the minimum standards not for load bearing, but for insulating materials. As I mentioned, the MOEs are not so good. So, but if you laminate it, then it's okay. So we want to use it for walls. If you put it there, the roof, then there's no load bearing there. You just place them so on the roof. So that's okay. So Hamed, we are at the beginning. This is the first project that we've done on geopolymers. So we are still learning about geopolymers. So there isn't really much that we can say about, but we are learning as we go along. So now I mentioned CLT. So here we have two students. Ayanda is one of them. Ayanda is looking at pine. So maybe before we talk about pine, I want to take you back and discuss this project. So South Africa grows pine, South Africa grows eucalyptus, and eucalyptus grows to pulp, right? And whatever is left, well, maybe that's not the right expression. We have huge amounts of eucalyptus chips that we export to Japan. Japan pays top dollar for this eucalyptus, right? These chips, because they do not have the capability of growing their own to the sort of volumes that they are looking for. So they import a lot from us. So of course, eucalyptus is not good for building material. It splits, it does all kinds of things. So now what we're trying to do is to make CLT out of this material. So it's still going to split, but you know, with CLT, you will have layers, right? Layer, top layer, middle, and so on. If it splits in the middle, you're not bothered by that because the other two layers are okay. That is because it's cross-laminated. So whatever split is there, it will be counted. So we're trying to increase the value of eucalyptus by making this material. It's a high-value material, right? But now, as I mentioned, in South Africa, we have to treat it with chemicals, something that other people are not doing, right? So what we want to know now is, if we treat this with chemicals, how does that affect the bonding? Because we still have to bond the leaves, that is the different layers. So how does it affect the bonding? So this project here on pine is a comparison. Pine representing softwoods that come from Europe, eucalyptus being the hardwood that we use. So Ayanda is looking at treatment mainly to induce fire resistance. He's going to use a material called Flambo. It's a borated preservative that will preserve the wood against degradation, but at the same time, it will enhance its fire resistance. So that is I think that is just the history of CLT. We know it started like in the 90s in Europe, and people are mainly using PUR and MF. So our aim, as I mentioned, is to see now if we treat this with chemicals, how or which of the binders will perform best in terms of, that is, once we bind it, we're going to test it and see if the treatment, because we just mentioned wood being anisotropic, so we need the pores for the chemicals to go in, but it is the same pores that we need for the bonding, isn't it? And also the rays, we need those for the bonding. But now if we clog those with chemicals, preservative chemicals, so how does that affect the bonding now? Should we treat before we bond, or should we bond and treat? So these are the things that we're trying to sort in this project. So yeah, I think these are some of the things that I've just said. So I think maybe this is the last one. So we want to investigate the performance of borate-treated CLT compared to untreated. We also want to determine the effect of different adhesives, as we mentioned, PUR and MF, in terms of delamination when it is exposed to fire. So what we are going to do, we are going to make a board, that is a CLT board that we are going to put in a furnace. Richard Walls, you saw earlier on, he's building a furnace that we are going to use to test these boards. That is, we look at the charring rate, because CLT is very big. It's not just going to burn like that. It's going to char like bit by bit. So, and also the design of the bonding. So how does it affect the spread of fire, or that is the charring? So like there, as you can see at the bottom, to examine the influence of CLT structural design on the occurrence of delamination, that is edge bonding. So this project specifically is sponsored by SAFCOL. SAFCOL is a government company. It's a government forestry company. So in general, these are the projects that we are doing. So we're looking at mostly fire retardant products for building applications. So as I mentioned, your geopolymers, phosphates, and so on. So this is what informs our involvement, especially with the group. That is, we're looking at geopolymers as fire retardant products to address this societal need. So, of course, we'd like to thank you for the organization to get us here. Goran has been writing emails back and forth, so eventually we are here. So we thank you for that, and thanks you for listening as well. So, questions? Yes.
You reported us on using borate as preservative and fire retardant.
Yes.
And the borates are quite under discussion in Europe because of health issues.
Yes.
Is it a topic in South Africa?
Yeah, actually, we can even go worse than borate. The rest of the world is banning CCA. In South Africa, we're not banning CCA yet. So we even went to court to prove that it is not the things that they say it is. So yes, of course the students, especially because CCA is still on the market, so we have to test it, right? But like for example, one of the students who's doing this project is always complaining he doesn't want to do CCA because everything he reads about articles, everybody's complaining about CCA. Yeah, borate, yes, it is not banned yet in South Africa. And this product here, Flambo, yes, yes. Yeah, you see, you say it is dangerous. We don't think like that. Yeah. So, yeah, I've just told you, we went to court to prove that it is not. You know, so.
CCA is...
No, I know, but about borate, you said that it's going to be forbidden.
Yeah, it's still allowed, but there's a big discussion that it will be forbidden because it's expected to have carcinogenic.
Yeah.
And it's used a lot in the food industry, actually. That's one of the reasons.
Yeah.
This is not the big problem, I think.
Yeah. Yeah.
Food preservation everywhere. Food is an issue.
Yeah. So yeah, of course we use borate to kill cockroaches. So it's a discussion as like